Hello guys, so today we are talking about ownership, which is a very important topic in Rust, and it will help you um, in programming Rust and make other concepts clear. So let's read few of these lines. So ownership is a set of rules that governs how a Rust program manages memory. Um, all programs have to manage the way they use computer's memory while running. So some languages uses garbage collection that regularly looks for no longer used memory as program runs. We will not read all of this text. So normally the language you might be using right now maybe JavaScript, maybe Java. Those languages uses garbage collector to manage memory, and we have manual memory management with programs or programming language like C and C++, but we have a new concept with memory management, that is ownership and borrowing. So we will talk about that in this video. Let's first understand what a stack and a heap is. So it is very important in understanding how a resource is managed and how the program is managing the memory behind the uh, site. So let's see. I will try to make you understand what a stack. Okay, stack. So stack follows a rule. So let's first Google search it. What is stack? Okay, so yeah, in computer science, a stack in an abstract data type. Which adds an element to the collection, and pops, which removes the most recently added element. So something. Okay, this image might help. Okay, so we first add 1, then we add 2, and we add 3. But when we are trying to get the information out, we select the uppermost element and we pop that element. The 3 goes out, the 2 goes out, and finally 1 goes out. So it follows a rule, something that is called uh, so sorry, that is called first in last out, FI yellow. So FI yellow. So let's consider this a box or a container. So we add 1 here, so 1 will be here. We then add 2, that will be 2. We add 3, right? 3. But when you are trying to get the reference or maybe getting the value of 1, then we'll try to iterate through the stack, something like 3. It will pop out, the stack will pop out 3, then the stack will pop out 2, and finally it will be 1. So that is stack. So what is heap? Okay, it is a little bit of theoretical tutorial here, but we still have a lot of coding to do, so it might be a little lengthier video. So hang on to this video, and I think you will have a lot of issues with Rust solved. Let's talk about heap. So let's talk about heap as something as a bag, and you might have all types of marbles, let's think of that. And every marble has a number, a set of number encoded in there, maybe 1, maybe 2, maybe 3, something like that, right? Every one of them has some numbers. So we are trying, when we try to deal with heap, then we do not know as where the 3 exactly resides in the memory. So heap and stack both are a memory that is allocated for use, but stack is a fixed type of memory, so where the size of the, maybe here you have stored a string, so it will have certain type of storage size. So let's see, so let's say string, and we might have, I don't know, maybe 4 byte or 8 byte, 4 byte. So it has a fixed memory size, and if you try to change it, this will not be that great idea. But when you are trying to deal with such changing values, maybe you need to change that size. It might not be the exact thing what you should get away from this example, but when you try to increase the number of datas that are stored, you do not know the length of the total data stored in the memory location. The stack will know, but the heap won't know. So that is heap, and that's the stack. Okay, so I think that covers heap and stack. Okay, so what is written up here? Many programming languages don't require you to think about the stack and heap very often, but in a system programming like Rust, whether a value is on the stack or the heap affects how the language behaves and why you have to make certain decisions. Okay, so here it is written that accessing the data from heap is slower than comparing to stack, because we already know how many data are there, and we can directly reference back to the data which we are trying to access. But in heap we have to look around in a lot of different memory parts to get to the required or given data location. So I think the theoretical part before has covered that. Okay, let's talk about ownership rules. So each value is in Rust has a owner. There can only be one owner at a time. When the owner goes out of scope, the value will be dropped. Okay, variable scope. So it has written, when the owner goes out of scope, the value will be dropped. Let's try to see that. Okay, let's create a block. Let val equals to maybe 8. Okay, let's try to print that. Print val. Okay, so this should give an error. Yeah, no, sorry, but the error was not what we are thinking about. Okay, so this is the exactly thing we are talking about. Val not found in this scope. So we have a block scope in Rust. So when we create two curly braces here, so that means a different block from the main block. But when we try to move this inside the curly braces, so this should now run perfectly fine. So yeah, it gives us value 8. So when the values the variable goes out of scope, then the variable and the data stored in it will be dropped from the memory. Yeah, that's the example. String type. Let's s equals to string from hello. Okay, put string appends literal to a string. Okay, will be mutated but literals cannot reference. Okay, so will this work? Let's try it out. I think this should work. Yeah. Hello world. Okay, that is really not what we are trying to learn here. Okay, scope is now over. We have already done that with data interact move x y. Yeah, so yeah, this we need to understand. Okay, let's try to print x. So will this give us error? So I say it will. Okay, that's not what we are looking for. I'm sorry. So we can probably guess starting binding 5 to x, then make a copy and bind it to where two variable can have both values equal. Intended with. Okay, this is fine, but I was looking for something different. S1. Okay, S1, S2 points to the same thing. Okay, this is in the same scope, and yeah, it will work. I'm sorry, I got confused. Okay, so let's try it out anyways. We did print y and we're trying to print x. Okay, so this only copies the value. So why isn't copying the value? Sorry, why is copying the value but not the ownership here? I got confused myself, so sometimes that's the problem. Okay, let's s1 equals to s. So I was looking for something like this. So but what does it say? The representation does not look like memory would look like if Ross instead copied the heap data as well. If Ross did this, the operation s2 equals to s1 could be very expensive in terms of runtime. Okay, we have this. Another possibility for what s2 equals to s1 might do if Rust copied the heap data as well. Earlier we said that when a single variable goes out of scope, Rust automatically cleans the heap memory for the variable, so the data pointers pointing into the same location. When s2 and s1 goes out of scope, okay, double free error. To ensure memory safety after the line s2 equals to s1, Rust considers s1 as no longer valid, therefore doesn't need to free anything when s1 goes out of scope. Check out what happens. So I was looking for something like this, and I know you guys are not enjoying this really much, but just stick for a moment. Okay, so now this will give us an error. And this is just so yeah, string time which does not implement the copy trait value moved here. So this s1 has the reference to string hello, and it's a stack type, and so we have copied the ownership from the value of ownership from s1 to s2, so the value does not exist in s1, or the s1 variable is dropped, so we do not need that, and it is a little bit different from what we can see from other programming languages. So s1 here has the s2 has the ownership now. So if we try to write s2, so this should give us the value hello. Okay, I'm sorry. Yeah, so it runs just fine. Hello world. So we got a problem here. While we are trying to do the same thing of with number. So if we make a, so I think we need to read that why this thing works but the number did not. So this works and this does not. So if you try to print y or x, that will be just fine. So why is that? So let's see that. And I got confused myself, so we can probably guess what is it is doing. Bind the value of 5 to x, then make a copy of the value in x and bind to y. We now have two variables x and y, and both equals to 5. This is indeed what is happening because the integers are simple values with a known fixed size, and these two 5 values are pushed onto the stack. Okay, so when we have something like integer or that has a copy, let's say trait for now, then it will be just fine for that. But let's do something like hello. Will this work now? X Y. So yeah, that just works. As this has fixed size, right? So we can push a string literal to it, so the size is not fixed. So it will be quite inefficient for the program to have reference to the same value by two variables, copying the values, and the values here are like 5 and we have given a reference. This is an slice type, so and that will be covered in this same video, and this video has gone a long duration, but still we haven't covered a large part of it. So this works, but the string type does not. So we have already seen this, so this does not work. But when we have fixed values with fixed length, then that would work in the same scope, that is. And the things that I'm talking about will be much clearer after some time. So way variables and data interact. Clone. If we do want to deeply copy the heap data of the string, not just the stack data, we can use a common method called clone. So we can use a clone variable to have multiple reference to the same variable. This works just fine and explicitly produces the behavior shown in figure. Okay, and heap data gets copied. So this data gets copied. Okay. Another summary report. Okay. It is visually indicated that something different is going on. So if you would like to copy the whole value from the string, so that is different from reference. We are not giving reference to s1, but if you would like to copy the value from s1, we do s1.clone or any variable dot clone, so that will copy the value, not the reference. So for reference we have something like rc or a slice type, or the reference type read only reference type. We will talk about that. Stack only data copy. So this will work just fine. So code seems to contradict what we have just learned, so I also got confused here. We don't have a call, we do not have to call to clone, but x is still valid and wasn't moved into y. So we have already talked what works and what does not. Ownership and function. So this is much of the interesting part we have to talk about. Okay, so a lot of things are given up here, but we'll try to make sense out of things, right? So string values go. Do we have something different here? Copy text ownership. Yeah. So we will talk about ownership and referencing in maybe a single example. We'll try to see that. Let's try to create a function add to 1, maybe 1 function. Let's try value, that's I32. It will let's not try it. Let's just print here. Okay, so print ln, we have to write val. So I'm trying to cover those both topics in a single example, so stick with me just a while longer to have all of this better understood. Okay, add to 1, maybe let's try it. Let int1 I32 equals to 1 int1. Okay, let's write let integer 2, that's also I32. We'll write 2, we'll copy the line, let's make it 3. Okay, we need to create another function. Maybe let's copy this 2 times. If I'm going a little faster, then just pause the video and go up to your own speed. So okay, value will be a type that is a reference to I32. Okay, and it will be an mutable reference to I32. So let's write mut. Add to, let's not try add to, let's try func1. Func3, I should have thought a little better, but just do this anyways. Func1, func2, let's give an reference to int 2. Let's do func3, let's give an mutable reference to int3. I think this should work just fine. Let's first go step by step. Let's try to run that. So, no, sorry, I'm getting confused myself. Let's try to copy that and paste and paste. Okay, so yeah, so the functions are working just fine, but what are these weird looking symbols, this ampersand and this ampersand mute. We have ampersand mute, that is I32. We have ampersand I32. What is even this? So you might be thinking, right, this is a little weird when you come to Rust ecosystem, Rust programming, and I too haven't seen all of these things. In C or C++, maybe some referencing with stars or something like that. Still, let's talk what these things are. So the function 1, int1, has given int1, just int1 with only variable name, nothing more. No ampersand mute. So this means that the function 1 now has the ownership to the variable that is int1. So if we try to print int1 just below the thing that is the function 1, we should get an error because we already have moved the ownership from the block that is main function to the func1 function. Let's try to run this and we should get an error. Oh, that's interesting. Okay, that is really interesting. Okay. So what is this? I mean, I myself is getting confused over all of these things. So am I leaving something? Okay, take ownership. Yeah, we have done this. Okay, I have done this. Makes copy. Okay, so again I made the same mistake. That is this thing right here. So as value moves into the function and so is no longer valid here, and this is an integer, would move into the function, but I32 is copy, so it's okay to still use X afterward. So we are making mistakes and learning, I guess. I mean, I'm still learning myself too, but it's an combined effort, I guess. I have used Rust a lot, let's not say a lot, but I have used for some of the projects, and still it gives me hard time. So I guess we are both learning here. Okay, so like the error we hit before the time. So when we have integer, so that will just make a copy and that won't get out of the scope. Maybe let's try it. str1 string from backend pin. Okay, let's give it str1. str1. So this should definitely give an error. Okay, let's something here. I'm doing mistakes left and right here. String. So yeah, that is the error we are looking for. Moves occur because str1 has type string which do not implement the copy trait. So the type that does not have copy trait will not have the ownership in the same scope after they have been moved. But let's try to do something like reference to slice string backend bin. Let's try to move str1. Let's change the type here, str. Now everything should be fine. Okay, expected. Sorry, there are times you do not like how Rust is tightly typed, but by times I think we will appreciate what it has to give us. So it just runs fine because the slice type has the copy trait, and trait is something that we are going to discuss, but giving you a heads up, traits are more like combination of abstract abstract class and interface. So that's more like that. So that's very broad definition I have given here, but still it has a different property that is not really something that you would see in class and interface, but that will give an overview as what traits are. So traits give some default behavior to types, and it can be used with classes, so more generalized type classes. So yeah, so let's go back to what we had. String, that is string, that's also a string. So talking about the ownership, so the ownership of str1 just moves to the function str1, and when the function ends executing, then the value and the variable will be dropped and we cannot use that anymore. If we use something like this, okay, ampersand means read only reference, okay, reference, read only reference. That means you can only read the data, and the ownership hasn't also been moved. So that means the function here, function to only have the reference to read only, and if it tries to write, then it will have an error. And the int3 means, sorry, the thing that is reference mut means read and write reference to the data. So in func3, we can mutate the data, that is value, and we can read it too. So that is the thing, and we still do not change the scope there. And the important thing, only one ampersand mute reference at a time, because if you try to change the value from multiple threads maybe, then it will have problem, because when we will try to edit the data from multiple threads, then it won't be thread safe, as the data would be written from multiple threads maybe at the same time, or read from same time, and that really cause inconsistencies in the value. So that's the thing. And while writing the function, we just keep the ampersand if it's a read reference, and we give the type that is given here as parameter, and we write ampersand mut and the type that is given as a parameter in the function. So that's the thing, most important thing in this topic. Okay, is there something more important than this? Okay, we have reference to yes, we have reference to yes. I think we have already talked about that. Yeah, so that one example really covers a large number of things that we are trying to understand up here. So okay, s length is a reference. So let's talk about this maybe the last time. So this is the major thing that you would need to take away from this video. So let's try to do a final example and be done with this video, because I think it has been a video maybe 40 minutes or longer, even I don't know. So what this does, let's try to see that by printing out the values. Slice, okay, we have two variables, that is slice, maybe something like that, but it will still give us error. Let me table slice, will this run? Okay, this should run. Okay, we have a but that won't matter anyways, because it is in the last line. So we have from 3, that's a reference to S, and this is slicing. So we are taking a reference to the memory location of this variable S, and we have value hello, but we're trying to reference the pointer of slice to the certain point of index, that starts from L and goes up to length, that is the length of the S variable. Okay, so this is an exclusive operation. So it does take the third index as the starting point, but it does not take the final number of index. So it has 1 2 3 4 5 will be the length. So index 0 1 2 3 4 5. So here would be 5, but it only takes up to the index 4, but we do not have index of 5 anyways. So yeah, that is all of that. So I think we have covered a lot in this video, and I think we will see about other interesting topics too. So let's close this video for now, and we will meet soon. So bye.